All right. Hey, my microphone went out on the last video. So that's what happened. I actually kept video recording and then realized at the end that half the recording was muted. So I'm pretty sure my voice works right now on this. So number 25 is where I'm going to pick up. The position of a particle moving along a line is given by this equation. For what values is the speed increasing? So do I have an understanding of what that means? So the speed increases when the velocity and acceleration share the same sign. They're both positive or both negative. So I need to find first the velocity, which is the derivative of what was given. So that's 6t squared minus 48t plus 90. Solve for t to know where the velocity is 0. So I'm going to divide everything by 6. I'm going to factor and then solve it. So at 3 and at 5 seconds, the velocity is 0. I need those numbers. Then I'm going to do the same thing for acceleration. I'm going to take the derivative of the velocity. That's 12t, subtract 48. Make it equal to 0. Add 48, divide by 12. So these are the numbers that I care about. 3, 4, and 5. That's where the velocity is 0 and where the acceleration is 0. And then I'm going to build up two number lines. So one number line is for the velocity. And one is for the acceleration. And then I'm going to go back into the equation and plug in values to know whether it's positive or negative. So if I go into the velocity and I plug in positive 1, it ends up being a negative times a negative, and that's positive. If I plug in a number between 3 and 4, you end up with a negative answer, just like you would end up with a negative answer if you plugged in a number between 4 and 5. If you plug in a number bigger than 5, the velocity is positive. So we're filling in the number line to know where it's positive and negative. For acceleration, use the acceleration equation. Plug in a number between 0 and 3, that's negative. Plug in a number between 3 and 4, still negative. Plug in a number bigger than 4, and it's positive for both. And what I'm looking for is, where do the signs match? So between 3 and 4, both are negative. 5 and more, they're both positive. So in other words, from 3 to 4 and 5 to infinity, this is where the speed is increasing because the signs are matching. Turn the page. And that matches with E. All right, number 26. The same question for number 26. Actually, for this one, it's same because it's talking about speed. So you're given the velocity and saying, where is the speed decreasing? So the speed is decreasing when the signs don't match. So when I look at here, what I'm looking for off the graph, if it's above, it's positive. And if it's below, it's negative for velocity. So for acceleration, I'm looking at increasing or decreasing off the velocity. So this is increasing and positive. That's positive, positive. This is decreasing and positive. These signs don't match. So from J to K, it's slowing down. If I look underneath the graph, it is decreasing and negative. The signs match. And on the other side, it's increasing and negative. Again, the signs don't match, so it's slowing down. So it slows down from J to K and L to M, looking off the graph. The answer is C. Turn the page. Number 27. For t is greater than 0, equal to 0, you're given the position. And then what is the acceleration of the particle where the velocity is first equal to 0? So first I'm going to find the velocity. That's the derivative of the position. So the derivative of sine is cosine, and the derivative of cosine is negative sine. But the two negatives make it positive. Now, I want to know where that's equal to 0. So it says where the velocity is first equal to 0. So I'm going to subtract sine t. Where are these the same on the unit circle, except one's positive and one's negative? So the first time that occurs is right here at 3 pi over 4. At 3 pi over 4, they have the same number, but one's positive and one's negative. Then I find the acceleration. So the acceleration is the derivative of the velocity. That's negative sine and positive cosine. And then you plug in 3 pi over 4. And then you have to know your unit circle. So if you plug in 3 pi over 4, what's the y coordinate at 3 pi over 4? That's root 2 over 2. What's the x coordinate? That's negative root 2 over 2. And then combine them together, you get negative 2 root 2 over 2. The 2's divide out, and the answer is negative root 2. Number 28. In number 28, a particle moves along a line, and you have a velocity, and what you're looking for is for what values of t is the speed increasing. So I'm going to graph that graph for number 28. I think I might have already done it. So that's what the graph looks like. So you can type it in and see the graph. And what are the things I'm looking for to know where the speed is increasing? So I'm looking for positive, that means above and increasing, and below and decreasing. So there's a little part there that's above and increasing, and there's a part there that's below and decreasing forever. So which one matches that I'm looking for? So this is what the graph looks like. And I'm looking for this part and this part, right? Those are the two parts. Above and increasing, below and decreasing. Which one could match that in terms of what it would compare on the graph? So when I look at those numbers, I can see off the graph that this is what's going to match it closest. So it's all like 0 to 1.2, and then right around 2 to infinity is where it crosses, just looking off the graph. This is the one that matches where the speed would be increasing. Number 29, that's just a faster way to do it. A particle moves along the x-axis, and you're given a position, and you're asked to find where is the particle at rest. So the particle's at rest when the velocity equals 0. To find the velocity, you take the derivative of the position. And this is going to be the product rule. So the first times the derivative of the second. Well, the derivative of the second is just positive 1. Plus the second times the derivative of the first. And again, a and b are constants, so the derivative of t is just positive 1. And then you make that equal to 0. And that's what we're going to solve. So if I combine like terms, this is what I end up with. I have 2t, subtract a, subtract b, equals 0. We're going to add a, we're going to add b, and then divide everything by 2. So add a, add b, then divide by 2. That's what I'm looking for. Turn the page. And the answer is B. In number 30, a particle moves, and the graph of the particle's position at time t is shown above from 0 to 6. For what values of t is the velocity of the particle increasing? So velocity is increasing when the acceleration is positive. So where is the acceleration positive? So for what values is the velocity increasing? So we need to understand concavity. So right here at 2, the concavity is negative, and then from 2 to 6, the concavity, the concavity is positive up to 2 and is negative to 6. So this is what I'm looking for. I'm looking for a positive acceleration. That means it's increasing, not the negative. So it goes from 0 to 2. That is where the velocity is increasing. Number 31. Question number 31. They talk about a particle that starts at 2, 0 and moves along the x-axis and with a constant positive acceleration. Which of the following could be a graph of it? So the distance between the origin and that point is the y value. So don't be confused to think it starts at 0, 2. So the answer is, at 0, how far away is it from the origin? 2. And I'm looking for a positive acceleration. That's concave up. That's what it means. So it starts at 0, 2, and it's concave up. So that matches with A. Number 32. Let f be a differentiable function. F at 4 equals 7. The derivative of f at 4 is 1/5. F is concave up. Which of the following is true about the approximation at 3.5? So first I need to find the approximation. So I'm going to write a tangent line. The slope is 1/5. And the point is 4, 7. So that's x subtract 4 plus 7. 1/5 is the same as 0.2. And then if I plug in 3.5, take away 4, that's negative 0.5. So if I put that together, the approximation is negative 0.10 plus 7, or negative 0.1 plus 7. So that's positive 6.9. So C and D are wrong. Then the second part is it's concave up. And if it's concave up, the tangent is below. It's an underestimate when it's concave up. So 6.9, and it's an underestimate. And draw yourself a picture if you need to. Concave up, draw a tangent line, see that it's below. The other way, if it's concave down, you can tell the tangent line is above, right? It's an overestimate. So the answer for B, 32 is B. 33. In number 33, it says you can use a calculator if you want. You're given the equation for the slope, or the derivative. And you're given a point. So I have an equation for the slope, and I have a point. So the slope is plug in 1 and negative 2. And then solve it. So this is 1/2. This is 4 divided by 4. So it ends up being 1/2 take away 1. That's negative 1/2. So the equation then is negative 1/2 x subtract 1 subtract 2. We're then going to plug in 1.3. So this is negative 0.5. If I plug in 1.3, you end up with 0.3. So if I put this together, I get negative 0.15 minus 2. So altogether, that's that. So I already know the answer is not A or B. And then the second part, is it an underestimate or overestimate? And we're told that it is concave up. So concave up means it's an underestimate. Put the tangent line, and you have your answer. Number 34. X and y are functions of time so that the sum of x and y is a constant. Which of the following equations describes the relationship between the two rates of change? So the sum of x and y is a constant. The derivative of x is 1 with this hook on with respect to time. The derivative of y is 1, but it needs the hook dy by dt. And the derivative of any constant is 0. Get dx by dt by itself, subtract dy by dt, and now you have the relationships between the two rates of change. So the answer to 34 is B. Number 35, Boyle's law, I think that's physics, maybe chemistry, states if the temperature of an ideal gas is held constant, then the pressure P is equal to K over V, where K is a constant. That is a famous formula. We're going to write this calculus friendly. So it's K times V to the negative 1. And then it says take the derivative with respect to time. What would that look like? So negative 1 times K is negative K. Subtract 1 to the exponent. And then the hook, which is dV by dt. So you will likely see this answer like negative K over V squared, dV by dt. That's what we're looking for the rate of change. So negative K over V squared, dV by dt. 36. A right triangle has a base of x. So I'm going to draw a right triangle, and the base of that is x. The height is h, and it says the angle is described by tangent, and the tangent of the angle is opposite over adjacent. So the angle must be here for this to be true. Tangent theta is h over x, and x is a constant. I want to find the rate of change of the angle in that triangle. So to get theta by itself, I'm going to do the arc tangent, or the inverse tangent, to get theta by itself. So now I have an equation that I can now take the derivative of with respect to time. So that's what it looks like. The derivative of arc tangent is a fraction. What you see, you take the derivative of, and that's the numerator. Remember, x is a constant. So when I take the derivative of this, it'll just leave me with 1 over x. Think of like 3 over x. If you took the derivative of, think of x over 3. If you took the derivative of this, you'd just be left with 1/3. So this is like 1 over x times h. And what you're left with is the constant, which is 1 over x. In the denominator is 1 plus, and then you square h over x. So that's really what it looks like. Now, that's not what any of the answers look like. So I have to algebraically change this. So I'm going to multiply this out. Just like that. And again, so I need the hook, right? dH by dt is the hook at the end. Now, how can I make it look like one of the answers that I see? I'm going to multiply top and bottom by x squared. That will undo the fractions. So if I do that, x squared divided by x, that's 1x. X squared times 1. And then the x squares divide out, and we have h squared. And that's it. So that's what I'm looking for. X over x squared plus h squared, dH by dt. And it is radians per second. And so that matches with A. 37. In question number 37, a particle is traveling on the x-axis, and you're given the velocity of that particle. Now, if you're given the velocity of that particle, if it's below, then the direction is negative, and if it's above, the direction is positive. If I want to find the total distance, I have to go and just look at each part separately. So you have to look at the part that's negative and look at the part that's positive and find the distance with both by subtracting in terms of what we're looking for. So for this velocity, you would go x at 0, subtract x at 2. So that's there. And then x at 4, subtract x at 2. This would give you the total distance. So the velocity gives you direction. So you know that you're finding the distance going to the left, you found the distance going to the right, and then you add both as a positive number. 38. An object moves along a straight line So at any time, its position is given by that. So what value of t is the object at rest? So we're going to take the velocity, that's 6 subtract 2t. We're going to make it equal to 0. So we're going to add 2t. We're going to divide by 2. And yes, it's that simple. At 3 seconds, the object is at rest. (39) A particle moves along the x-axis, and you're given its position. X at t equals that, where t is the time and a is a positive constant. At what time t is the particle position furthest to the right? So we need to understand the velocity and the direction it's going. Velocity gives me direction. This is going to be the product rule. That's the first times the derivative of the second. So for e, you copy it, and then the derivative of negative at is negative t, plus the second times the derivative of the first, which is just 1. So if I put that together, negative t times t is negative t squared. All right, so next what I would do is make it equal to 0, and I would factor to solve it. So what do they have in common? Is e to the negative at. That leaves me with negative t squared plus 1. Now I want to know where the velocity is 0. So e to anything will always be a positive number. It could never be 0. So this is the only factor that I'm going to make equal to 0. I'm going to add t squared, and then when I square root, I get 2 answers. Positive 1 and negative 1 gives me the answer 0. Now, in the question, it says t is greater than or equal to 0. So it can't be negative. So t equals 1 is what I'm looking at. So for our velocity there, t equals 1. So it starts at 0, it goes to the right. At 1, the velocity is 0. So what would happen if I plugged in a number between 0 and 1 for t? So if I did that, remember this will always be positive. If I plugged in 1/2 or 1/4 or 1/3 and square it, this would give me a positive answer times a positive answer. So this way it's going to the right. If I plug in a number that's greater than 1, like 2 or 3, you'd square it and then negative plus 1. This would give me a negative answer times positive, which is negative. So this particle is moving to the right, and then at positive 1, it changes direction and it goes to the left for the rest, forever to the left after that. And the question is, at what time is the particle's position farthest to the right? So wherever it started, it's going to go to the right up to 1, and then it's going to change directions after that. So I get the answer at 1 second, or at time equals 1, it will then be furthest to the right. When I look at the answers, I don't see that answer that I want to. So I'm going to change it, and I'm going to say the answer is 39A. It's 1. I'm going to go with it. Number 40. The volume of a certain cone for which the sum of the radius r and height is constant is given by this formula. So we have V equals 1/3 pi r squared 10 subtract r. You're given that. And it says the rate of change of the radius of the cone with respect to time is 6. So dr by dt is equal to 6. And in terms of r, what's the rate of change of the volume? So can you find dv by dt using that formula? So first, before I take the derivative, I should actually first distribute. Or I could do the product rule. What did I do? I could do the product rule too. So the first is 1/3 pi r squared times the reciprocal of the second, which is -1, plus the second times the reciprocal of the first, or the derivative of the first. So that's 2 times 1/3, and then subtract 1 to the exponent, and then we need a dr by dt at the end. for that hook. We're then going to write this so it's going to match one of the questions. So dr by dt is 6. So I have 1/3 pi r squared plus 10 subtract r 2/3 pi r, and all of that times 6. So 6 times 1/3 is 2 pi r squared. 6 times 2/3 is 4. That's 4 pi r. And then we might need to simplify this just a little bit. So we have 2 pi r squared. We have 40 pi r minus 4 pi r squared. So we have 2 pi r squared minus 4 pi r squared. I think I lost a negative in there somewhere. I did lose a negative in there. So do you see how there's a negative in there? I lost that negative. So I shouldn't lose that negative. So this is negative. So -2 and -4 is -6 pi r squared plus 40 pi r. And there's your answer. So the answer is E. Number 41. The radius of a circle is increasing. At a certain instant, the rate of increase in the area of the circle is equal to twice the rate of its circumference. And this is, what is the radius of the circle at that instant? All right, so the area of a circle is pi r squared. If I take the derivative of that, it'll be dA by dt equals 2 pi r, and then the hook, dr by dt. For a circumference, it's 2 pi r, and then the rate there, the derivative, would just be 2 pi, and then the hook at the end would be dc, or dr by dt. And then the relationship between these two rates, I make them equal to each other, but one is going to be twice. So the rate for the area is twice that of the circumference. And that's what I'm going to solve. So some things divide out here. So 2 pi divides out r. Oh, why is there an r there? There should not be an r there. Okay, so 2 pi divides out. What else do they have in common? Dr by dt divides out. So all that leaves me with is 2r equals that just leaves me with r is equal to 2. That's all that's left. So the 2 pi's divide out. The dr by dt divides out. That leaves me with r is equal to 2, and I have my answer. Number 42. A sphere is expanding in such a way that the area of any circular cross sections through the sphere center is increasing at that rate. So the area of a circle, and dA by dt is 2. The volume is 4/3 pi r cubed. And now I'm going to take the derivative of the volume. My goal is to find what is the rate of change of the sphere's volume. So that's dV by dt. That's my goal. The derivative, 3 times 4/3 is just 4. Subtract 1 to the exponent. And then dr by dt is the hook. Now, if I take the derivative here, dA by dt is equal to 2 pi r dr by dt. That's the derivative with the hook. I'm going to take that value and I'm going to come back into here to do a substitution. So I'm going to rewrite this as 2 pi r dr by dt. And then I still have 2r at the end of that. So if I multiply these together, I get 4 pi r squared dr by dt. But why did I do that? Because I can now substitute that out. So 2 pi r dr by dt is what? dA by dt. So I'm just going to plug that in. And it says the radius is 4. So I do need that value. And now I just plug in. So dA by dt, it tells me is 2. And then 2r, which is 4. And then if I put all of that together, the answer is 16. In its volume, so it's centimeters cubed per second. Number 43. Number 43 is a calculator question for sure. And so you're given the fuel consumption of a car. So you have fuel and speed. And it says if the car is traveling 50 miles per hour and its speed is changing at a rate of 20 miles per hour squared, that's the derivative. At what rate at which its fuel consumption is changing. So we need to take this derivative with respect So we're going to take the derivative, and then the hook is the derivative of s, like the chain rule. In the question, it says take the derivative and plug in the speed, which is 50. And then we're going to multiply that times ds by dt, which is the change in speed with respect to time. And that number was 20 that was given. And this is what I'm going to type in the calculator. I think I already did this for it in the calculator. Let me just see quick. So this is what it looks like. So take the derivative and then evaluate it at 50, and that's the answer. And then once you have the answer, you multiply that answer times 20. And this is the answer you get. 4.299. So that answer matches with B. 44. I found this one to be the most challenging one. In the figure, PQ represents a 40-foot ladder with end P against a vertical wall and Q on the level ground. And it says P, that the ladder is falling, which means Q is going in this direction. And it says the rate is 3/4. So I'm going to call this P and this Q in terms of distance. And go from there. Let me just do this 1 second. Hello? Okay, thank you. All right, we're almost done here. Okay. So in the question it says that Q is moving 3/4 as fast. So dQ by dt is moving 3/4 as fast as P is going down the wall. So that's the relationship. I found that best thing to do at this point is to take and integrate this. So you can see that Q is equal to 3/4 P, and that we now have a relationship to now find the sides, because our whole goal is to figure out what Q equals. But now I can write it in terms of Q to be able to use the Pythagorean theorem. Now I don't want to know what Q equals because I want to keep Q. So I'm going to do the reciprocal and figure out that if I do the reciprocal, 4/3 Q is equal to P. This is what I'm going to use. So here I'm going to do the Pythagorean theorem. So it would be P squared plus Q squared equals 40 squared, right? It would be that. But I'm going to take out the p and put in 4/3 q squared. And this is the equation I'm going to solve. And at that point, what q equals is the answer. I honestly, you think you should use a calculator here, but it's fine. 9 over 9, that's 25 over 9. Ultimately, this is what's going to give you the answer. To get q squared by itself, do the reciprocal. And then finally, you do the square root. 1600 times 9 over 25. I think that's too heavy lifting without a calculator. So to do all that, the answer would be 32. All right, 45. Question number 45. We have a diagonal in a rectangle, but a diagonal, and you can see a right triangle here. The relationship between the three sides is obviously the Pythagorean theorem. So it's x squared plus y squared equals z squared. All three sides are increasing over time, so there's no constants. So you take the derivative. So the derivative of x squared is 2x, but it needs the hook with respect to time. The derivative of y squared is 2y, but it needs that hook with respect to time. Same thing with 2z. It needs that hook. And now once we did that, we need to start plugging in values that we know. So it says x is equal to 4. So I'm going to plug that in. dx by dt is equal to dz by dt. So I'm going to take it out and put in dz by dt in its place. Y is 3, and it says dy by dt is k times dz by dt. And then the last one, you're not given what z equals, but we can figure it out. If this is 4 and this is 3, this is a 3, 4, 5 triangle. You should have that memorized. So the hypotenuse is 5. So that's z. And now we only have one rate of change, dz by dt. I can actually divide them out. So each term has it. So I can just divide it all out. And I'm left with 8 plus 6k is equal to 10. And that's what I'm going to solve. So subtract 8, divide, and you have your answer. So the answer is 1/3. It's B. 46, very similar. So in question 46, again, you have this right triangle. The relationship again is x squared plus y squared equals z squared. I'm going to take the derivative again, exactly what I did before. And we're taking the derivative with respect to time. So there it is. Now I'm going to plug in the values that I know. So it says x is 4 again. dx by dt is, I don't know. Oh, it's 3 dy by dt. So we'll take it out and put in 3 dy by dt. Y is 3. I want one rate of change. Z is exactly what we did before. So it is a 3, 4, 5 triangle. So Z is 5. And then it says dz by dt is equal to 1. Right? All right. So now I only have one rate of change. So I'm going to combine like terms. So this is 8 times 3. That's 24 plus 6. That's 30. And 10. Divide by 30. And you get 1/3. So dy by dt, we have solved it. It's 1/3. dx by dt is what I'm looking for. It's 3 times that. So it's 3 times dy by dt. So 3 times 1/3, and the rate of change for x is positive 1. All right, number 47. 2 left. Sand is deposited into a pile with a circular base. The volume of that pile is r cubed divided by 3. It says r is the radius of the base in feet. The circumference is increasing at a rate of 5 pi. When the circumference of the base is 8 pi feet, what is the rate of change of the volume of the pile? All right, so I'm given circumference, but my formula says radius. So I have to do this. Circumference is 2 pi r. To get r by itself, I divide by 2 pi, and now I can do a substitution and into this formula. So now this formula is going to say c divided by 2 pi cubed over 3. And now I'm going to take the derivative with respect to time of that equation. So 3 times 1/3 is just c over 2 pi, and then subtract 1 to the exponent. The derivative of c over 2 pi is 1 over 2 pi. And then remember that if it's a variable over a constant, when you take the derivative, you're just left with 1 over that constant. And then the hook, which is dc by dt. Now we have values to plug in. So the circumference is 8 pi. And the circumference is changing at a rate of 5 pi. And that will give me the answer I'm looking for. So 8 pi divided by 8 pi is 4 squared. 5 pi divided by 2 pi is 5 over 2. So this is 16 divided by 2 times 5. So the answer is 40. And you have it right there. All right, last one, number 48. This one's actually really easy. So have the energy, you can do this one. For the function, you're given the derivative, 2x plus 1, and f at 1 equals 4. So x is 1, y is 4. The slope, it comes from the derivative. Plug 1 in, and you get 2 plus 1, so the slope is 3. So the equation of the line, the tangent line, is 3 x subtract 1 plus 4. That's from these numbers. Then we're going to use that to estimate 1.2. So if I plug 1.2 in, 1.2 take away 1 is 0.2. 0.2 times 3 is 0.6. And then if I add them together, it's 4.6. And it's over. That's the answer. All right, that's it, Mr. G Math. I'm so proud of you that you got to the end of this review. I know this was not an easy chapter, right, to review in terms of derivatives, related rates, and the work and thinking geometry that went involved here, trigonometry, L'Hopital's rule, a lot of stuff. So I'm proud of you for practicing and not giving up. Till next time.